valuation opportunity for us to say the project is crazy hard, you're nuts, or easy, or perhaps suggest how you can make it more interesting or more flexible or whatever. It is not too early. This is, of course, it is not too early to start thinking about your final project. How many people have an idea for a final project? Alice, of course. Are you all partners in the lab too? Oh. So what do you guys want to do? What do you want to do? Oh my God, radar? Sure, why not? It turns out that this is feasible, possibly feasible, for the first time this year because we're changing architectures. It's no longer going to be an 8-bit Atmel course. It'll be a 32-bit PIC course. And the 32-bit PIC architecture has a CTNU, a charge time measurement unit, that allows nanosecond resolution for short times. So you can expect, anybody know how long 1 nanosecond is in feet? Light feet? Nice place, right? Great. Okay. The rule for 1 year, if you go back and look at the videos on YouTube for the course, there's a YouTube channel, ECE4760, also to look at. I think 4 years ago, people did a grapefruit slicer, which had a turntable, a servo motor from a CD-ROM drive, and a big knife. And before I would let them do this, they had to get the safety interlocks correct. So that, and we're not putting software interlocks here, that's not good enough. When you take the cover off that, it's got to cut the power to the CPU. That's good enough. So, physical interlocks before you make the spinning blades. The consulting schedule is here. You will find that TAs are going to consult during lab periods. There'll be a TA in the lab section. There'll be a separate teaching staff who will be consulting and helping with the lab. I will be in 3 of the afternoons. You'll notice there's no section Wednesday afternoon. I'll be there anyway for people who want to come in and work a little more. I'll probably also open up on Monday and or Tuesday morning, although not next week, for more lab time. The dates for, now to go back to the assignments, homework is due at the time mentioned here. The lab assignments are the weeks mentioned here. I'm not going to say this again. It's on the web page. Don't ask me. Look it up. Yeah, just look it up. The design project will be demoed, is due the last week, the last regular scheduled lab session that you have. So Tuesday will demo on Tuesday, Friday will demo on Friday. At that time, you have to have a working demo and a rough draft of the final report, which is a web page. The final report is a web page. You have to turn in the web page, the final version of the web page, on the date specified. I can't tell you what it's going to be because it's the date specified by the university. It's consistent with the rest of the final exam schedule and the time that this class meets, but it's not published until about 4 weeks before the end of the semester. So we'll know when that is, but it will be something like, it will be between 0 days and 5 days after the last class. There will be optional extension, an optional no penalty extension into study days for demoing the project. So it will probably be more like December 6th or 7th. Any questions? Why pick 32 rather than Atmel? Well, Atmel actually has 2 32-bit lines. They have the AVR32, and they have a couple of ARM variants. And I think that the PIC32 is easier to teach. That's why we chose it, we being Amiga. And I think that the register structure and the interdependency between program pieces is easier to understand. Now, this is somewhat subjective, right? It happens to fit into my brain better than ARM does. But we'll see how you like it. That's a caveat for this year. As of last year, I've been using AVR for 17 years. I knew a lot about AVR. This year, I've been using PIC32 for 11 months. So, I know how to make it operate. but I don't know the failure modes. And experience shows that students pick up an amazing number of failure modes. So, I'm not trying to be mean here. It's really easy to misset a bit and in a register someplace. And with the ADR, I can say, oh, well, it's doing this, it's not doing that. Probably you didn't set the timer right. I can't do that with this architecture yet. So, the TAs, me, and you are all going to learn this together. Depending on your personality, that can be daunting or exciting. But think carefully about this. The new architecture, I threw away every bit of hardware and replaced it all with new hardware. Threw away every bit of software and rewrote it all. Any questions on that? This is a standard NIPS M4K core. It has the usual set of timers, A to D converter, SPI channels, UART channels, like any microcontroller does. It also has a feature that is not on AV, and that is a direct memory access channel. It's a 4 direct memory access channel. In fact, the memory controller has at least 7 bus masters. There's the instruction master for the CPU. There's the data master for the CPU. There's the data master for the USB on the go. Ooh, something else with it. And then 4 bus masters for each DNA channel. These 7 bus masters can target 4 different targets. They can target flash, where the instructions are stored. They can target RAM, where data is. They can target USB, which has its own memory target, or the peripheral bus, where almost everything else is. So you can issue 4 bus requests on every cycle and have them fulfilled. This is very cool, very powerful, and slightly confusing. So, concurrency, remember folks, 3140, prerequisite to this course, covers concurrency, interrupt service routines, I/O ports in general, 3140 for the Texas Instruments device, they're all about the same. And I expect you to know that already. So, the details of concurrency due to the DMA accesses, you should have some idea how to handle, but we're going to talk a lot more about that. There is no yes. Pardon? How many people in lab groups? I don't want any more than 3. 2 is probably better in terms of hands-on. If you have a compelling reason to go to a group of 3, I will do that. The final project, if you pick some gigantic, horrible thing, like radar, and want to have a group of 4 or so, I can do that. We've had trouble in the past making sure that everybody works the same amount in a group of 4 or 5. And we do reserve the right to differentially grade members of a group if one person is slacking. There is no text. There's plenty of documentation, folks. There's a reading list starting here, all semester. You're going to refer to this over and over again. There's a user's name for the oscilloscope. Fantastic. For the signal generator, the PIC32 reference manual you're going to use all the time, because this describes the programmer's model, the programming model for the CPU. It describes the registers and how they interact with the hardware. So this is going to describe how you control the peripheral. It is 1,130 pages long. You won't read all of it probably, but you'll read a good section of it, because there is no other way to figure out what stuff does. I've read probably a third of it so far in the last year. PIC32 peripheral libraries for MPLAB C32 compiler, which is what you're going to be using, tells you how to bind the description, the hardware description found in the reference manual to C. It tells you how to manipulate the registers using C macros, mostly in a few functions. Mostly just handy ways of laying out very arbitrary bit fields so that they're easier to remember. The PIC32 data sheet has the gory details of how the pinout, and this chip comes in several pinouts. We're going to use the 28-pin TDIP. The nice thing about using TDIP is that when you blow out the I/O ports, you can replace the CPU. Not that you will, but you probably will. And that's okay. This is a hardware course. We can't learn to build stuff unless you learn to break stuff and fix it. The current limit on the I/O pins for this CPU is what? How many people have read this? By the time you get finished with the homework, you'll know that number. You'll also know the Thevenin equivalent resistance of the I/O ports, because that is going to matter. We are not going to use them only as logic levels. We're going to be using them as analog voltages. And therefore you have to know their impedance characteristics. Or you can blow out the port by hooking an LED to it. That's really important. Can you drive a 4-ohm speaker off of an I/O port? Yes or no? Who wants to hazard a guess? Exactly right. Don't do that. It will just toast the I/O port. And you might want to read the MTLab IDE users guide, because that tells you how I like to use the software. I can't read the software manual, so I don't expect that. Specifically for Lab 1, I want you to read reference manual sections 12, 14, and 15, take peripheral libraries for MTLab C32, 10, 11, and 12, which correspond to these sections. Why did they label them the same? I don't know. And you might want to be getting started with PIC32. That's kind of a chatty introduction to the architecture. And required reading is the class overview and policy. In fact, we're going to talk about that right now. So we're clicking that link, because this is the contract you are signing by taking this course. This is what you agreed to do. There's a little section on reading here, which I talked about. This is a design course. We're not going to tell you how to build this stuff. We're going to help you figure out how to build it, but we're not going to tell you how to build it. There are lots of ways of implementing most of these projects that you're going to be doing. There's no single right way. There's lots of wrong ways. But there's no single right way. And so you may find some very clever ways of doing it. That's okay to do. So we're going to expect you to show more about creativity and flexibility and motivation to come in and work on these things. Strategies for what we expect. It's a culminating design experience course. That means we can ask you anything from any course. In particular, I like differential equations. And so a lot of the projects that I pick up are differential equation based, like Lab 3. Will be a video game. It's a video game I made up, so you'll never find code for it anywhere. It's called Particle Beam. And what you do is you have to deflect billiard balls in pockets on the fly. So you have to do billiard ball dynamics. So it's vector calculus, really, to make it go. There's 4 projects, plus a final project, 4 specified projects, plus a final project. 50% of the grade of the course will be in the laboratory assignments, of the 4 lab assignments. Of that, 25% will be how ready are you to go when you get to lab? Have you done the reading? Do you have a code draft ready to go? Or are you still flipping through the book and say, which way is up on this web page? Right. 25%. 25% will be, did it work? Did you meet all of the design points in the assignment? The last 50% will be the write-up. Write-ups are important. Take it seriously. Particularly, you come in, you work hard, what happens, you can't figure out what's going on, nothing works, you make a good write-up. Well, it didn't work, you put it 75%. If you work hard, you did a good write-up. So this is to redeem yourself if the whole thing fell apart. But, experience shows. Starting early. Think about the code. Think about the structure before you start banging on the keyboard. Think about the goal of the project, which is to some extent getting inside my brain. Will make a successful project to get you most of the points. You have to attend your weekly scheduled lab period, even if you finish the lab. Let's say you're an ace programmer. You come in, you whip out lab 1 in one lab period, you demo out during the first lab period, you must show up for the second lab period, or you will lose 25% of the points for that lab. You can always start on the second lab, you start on the final project. There's always something to do in lab. It's take at least an hour and a half in the lab, even if you finished it. No late assignments, except of course for sickness or family emergency, the usual. Lab work is done in groups of 2 or 3. Collaboration is required within the group and forbidden between groups. We'll talk about that. 50% of the final project. Since everybody does a different project, it's really hard to grade these. So what we end up doing is to try and rank order them, but not necessarily by cleverness, although that counts. total work certainly counts a lot. How much time did you put in? Did the final result match your specification that you gave us 5 weeks before? But the fact that this is subjectively ranked is inescapable in a course that has open design. If you don't like it, don't take the course. Final project will be broken down about the same way. I think the breakdown size, I believe, is 20% on effort, 30% on result, 50% on lab write-up. There will be a bonus for getting done early. It goes as the square root of the number of days early. I love these nonlinear things. But there's a sweet spot around 7 days where the trade-off is pretty good. This is designed for a couple of reasons. One is it tries to keep the TAs and me from going nuts the last 3 days grading 50 or 60 projects. And secondly, it's kind of like real life. I mean, you get a bonus for getting done early. And lastly, you may help your grade by participating in class discussions and asking questions in class. And excessive non-attendance in lecture may lower your grade. Excessive non-attendance. 2 years ago, there were a couple of people who never came to lecture. They lost the course. I don't often use this, usually only if it's egregious. If you feel you've been unfairly graded, you have 1 week from the time the assignment is handed back after regrade. There are no tests. I think tests are useful for the design course. There's some laboratory policies, but each senior course is expected to abide by Cornell University Code of Academic Integrity in the context of this course. You're certainly allowed to talk in lab. If somebody else in the lab says, hey, what's the name of that register? You don't have to say, I can't tell you, you're not in my group. You can, of course, tell. So the breakdown is basically that as long as you're talking, if you're talking to somebody about code or about their hardware, that's fine. As soon as you pick up the mouse and move the mouse for them, or put a wire in their whiteboard, that is not allowed. So, allowed, homework and code must be shared within a group, and not allowed is sharing any material between groups. Allowed, talking in lab about code with another group. Not allowed, emailing code to another group or using another group's keyboard to enter code. Allowed, showing the other group your circuit. Seems reasonable. What do you mean by SPI? Where do those wires go? That's fair enough. Okay. What's not allowed is wiring for another group or lending them your circuit. I've seen that happen. See, this looks familiar. I have a pretty good visual memory for circuits and for artifacts in displays. So I can often detect copy code by the way the TFT boots. I'm not kidding. Not allowed to copy anything, even one sentence from any web or printed document unless it's quoted. It's really easy, once you get in the habit of this, to detect words from Wikipedia. There's a style that Wikipedia encourages. You get somebody, we're writing along, and somebody does this thing, is boilerplate sales speech. Wait a minute. So don't do that. Allowed is using code for final projects for web sources with attribution, but not allowed is without attribution. That's going to be a relatively limited use this year, because there's no code for PIC 32 from the course. So you're going to be writing the code basis for next year's class. Yeah. The section on lab reports, next year, obviously you're going to read that. But also, you might notice, right here, are some PDFs of good labs that you might want to read to see the level of detail we expect in a lab report. They won't be literal because, of course, these are all AVR, but this will give you a level of abstraction that you need to understand. Read this page completely. You are agreeing to it by taking the course. You better know what it says. I used to give a quiz on this page. I can still do that. Any questions about the logistics? Yeah. Your lab partner must be in the same lab section. You will be in your scheduled lab section, and your lab partner must be in the same lab section. If during final project you want to make a group that spans lab sections, then the demo will be due at the earlier lab period. I've seen this one before. Yes. Homework is required to be done in a group. One homework